from a broken home. I gave you all the bricks that I own and know. I'm letting go. I'm breaking these walls down, breaking these walls down. If you want adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. I'm tired of the pain. Go away. I'm tired of yesterday. Father. I fell where my demons dwell. My own little nightmare, I call it hell. Oh well, it's time to get back up. Climbing and climbing, I'm done with this ride, is what I tell myself, so I could feel something else. Yeah, I guess I had my bad days, but it doesn't mean I lost myself. Darling, where were you when my heart was on the ground? I thought time would prove that you would stick around. I guess time stood still, a king without his crown. Now I'm breaking, you're faking, girl. You never made a sound. I'm tired of the pain. Go away. I'm tired of yesterday. Father.
Hello, everyone. Welcome again to another edition of our cloud security meetup. It's a wonderful session, Sir David. How are you doing?
Yeah, doing very good. And thanks very much to everyone for joining us today. So I'm glad to have, my greatest sir himself back. He's back from all the different investment trips that he's been doing. So glad to have you back. So we do have we do have a very interesting session today. So we have a guest speaker, but before we go ahead and introduce the guest speaker, let's just do some quick housekeeping. If you're yet to join the cloud security user group, please ensure that you use the Meetup link that we're going to be posting in the chat window, and ensure that you join using that Meetup link. So that's where you can be notified of any upcoming sessions that we have. So we have a lot of exciting upcoming sessions. So they will be speaking to us today. So we have Dayspring Johnson, but we also have Christoph. We have David on Wukwe. We have Martin Gort that will also be speaking to us on different aspects of Azure security research, Azure offensive and defensive security. So lots of exciting sessions coming up. So, Sir Coffee, shall we go ahead and introduce our speaker for today?
Yeah, absolutely. So let's bring Dayspring on the line.
Yeah.
All right. So
Hello.
How you doing?
I'm doing all right. How about yourselves?
We're doing quite well. We are just amazed that you actually gave us the opportunity to give us more information in regards to security in Azure. So I've been looking at your YouTube channel, so it's kind of amazing. So we're definitely looking to today's presentation.
Absolutely. I appreciate you for inviting me over.
Yeah, and Day's been really involved, especially in the cloud detection engineering side of things. He introduced himself, I'm sure, but he's a cloud detection engineer at Datadog, and is a view specialist at what he does. So as a community, we're looking to just take in whatever information just to remind the audience, if you have any questions as they go through a session, please do put your questions in the chat window, and we're going to be reading them out today throughout the session and the presentation. So that being said, we'll hand over to you and let you go ahead and introduce your topic and then take us through that.
Sounds good. All right, do we have the slide shown? Okay, sweet. Awesome. So, hello everyone. Today I will be speaking on cloud detection engineering in Azure. And just a brief introduction of myself. I am a detection engineer at Datadog, where I work on the CloudStream product. I'm also currently pursuing a degree in information technology at WGU. I also make content on YouTube for cybersecurity, cloud security. Also the founder and community manager for CyberArks Academy, where I, interact with entry-level cybersecurity people and just kind of help them in navigating your journey to get into cybersecurity. And then also recently became an AWS community builder and a cybersecurity tutor. And you can find me at all of these links on here. All right, so just an agenda for today. We're going to be looking at cloud detection engineering in Azure. So this is going to be like a slightly technical, but also not as technical talk. So basically, I'm going to be going over end-to-end overview of how to approach detection engineering for Azure environments, but all of these concepts can also apply across various cloud environments as well. So we'll take a look at why we need cloud detection engineering. We'll also look at the differences between traditional detection engineering and cloud detection engineering. We'll define what cloud detection engineering is, and also how to approach cloud detection engineering, how to implement it, how to operationalize it, and then a final roundup of everything. And the slides will be available on my GitHub page, which is you can find it at DayCyberWalks. So with that being said, let's start with why we need cloud detection engineering. So over time, in terms of security, adversaries have typically been ahead of defenders, right? It's usually the breach before the attack, the breach before the investigation or the response or the detection. So attackers will compromise environments, and then defenders will scramble to investigate what happened and then try to create like signatures or detections so those things don't happen again. So in this case, defenders have always been reactive and rather than proactive, because like we typically wait for bad things to happen before then responding to them and then creating guardrails against them. So with that being said, the traditional IDS and IPS systems we have are no longer enough. And we also need to know when some of our preventative controls fail. So what if we put something in place to stop attackers? How do we know if that thing fails? And this is why we actually need cloud detection engineering. So like I said, traditional detection engineering versus cloud detection engineering. Sorry if there's like some errors in the slide. I just converted this to PowerPoint just a while back. But traditional detection engineering versus cloud detection engineering, as you can see on the left-hand side, you see how organizations are typically structured, and you can see that the detections are in place at certain areas of the network to detect activities for like your workstations or your servers, or your DMZs, your demilitarized zones, where you have certain assets that you might want to be accessible from the internet and stuff like that. But when it comes to cloud environments, there are different considerations you have to consider for your cloud environments, and in this case, Azure, right? So we see there are different things we have to consider, different resources, different tools, and also like different things in terms of like the operations of the detection that we have to consider. So there's as you scale in the cloud, it comes with more complexity in terms of how do we actually create detections and make sure that these detections are working as they are designed. So we go ahead and take the proactive approach. So what if, as defenders, we get to be a step ahead of our adversaries? What if we can build guardrails around our assets to determine, if anyone is performing any sort of suspicious or anomalous activities in our environment? What if we can actually build custom and advanced detection mechanisms to understand if adversaries are trying to attempt suspicious or malicious activities in our environment. This is where cloud detection engineering comes in place. So what exactly is cloud threat detection engineering? Cloud detection engineering is the process of designing, implementing, and maintaining systems and controls that identify anomalous activities in our cloud environments. And this was just something I pretty much coined based off of what the actual purpose of detection engineering for cloud environment is. The goal is to create, design, and implement systems, and these systems could be anything from actual tools or the actual detections themselves. But anything you do in terms of designing and implementing and maintaining anything for identifying anomalous or suspicious activities in your cloud environment will fall under the umbrella of cloud detection engineering, and in this case, specifically for Azure. So how do we actually approach cloud detection engineering? Now that we understand why we need cloud detection engineering, and now that we understand what exactly cloud detection engineering is, how exactly do we approach it? So the first thing we have to consider is our adversary. This is the person that we're considering in terms of why we are actually building this detection. So the first thing in terms of the adversary is understanding who the adversary is. Who is this person that we are creating this detection for? And what is their persona? And this adversary sometimes, a lot of times when we think of adversaries, the first thing that comes to our mind is hackers or advanced persistent threats. But the adversary could actually even be insider threats. They could be your security engineers or even privileged administrators in your environment, or your employees from other departments like your marketing department, whatever the case may be. An adversary could potentially be someone working in your organization. And of course, there are other advanced cases like adversaries with different motives, like APTs or adversaries who might be financially motivated. But the first thing to understand is who exactly is the adversary. The next thing after understanding who the adversary is what is the goal of the adversary? What exactly is the adversary trying to achieve in my environment? And this is where the tactic comes in. And the tactic is essentially the high level objective of the adversary. It doesn't go too deep into what the adversary wants to do, but at the highest level, what does the adversary exactly want to do in my environment? And in this case, it might be anything from like gaining persistence or even gaining initial access into the environment. So this is where we define the adversary's goal. After we define what the adversary's goal is, we then go into defining how will the adversary actually try to achieve this goal. And this is where we dig deeper into the technique the adversary would take to achieve their initial goal of either initial access, persistence, or whatever the case may be. So in this case, if we're looking at an adversary who's trying to establish or maintain persistence in your environment, for an Azure environment, one good way of maintaining persistence is through automation accounts. So this is what the adversary is actually doing to maintain the persistence. And after we've identified that, we then look at what tools or what exactly what process is the adversary going to take to achieve their goal. And in this case, we take a look at the procedure. So is the adversary going to use specific tools? Are they going to make manual API calls? What exactly is the process the adversary would take to achieve their high level goal of the tactic or the technique? So after we've identified the adversary, we now have to start considering various things to understand how we're going to look at the adversary's activity and detect the activity. And what comes to mind for this is observability. And observability has various considerations. The first consideration is telemetry. So in this case, we're looking at different things from how do we get visibility into our cloud environments, and how do we get visibility into the different altitudes of our cloud environment. And if you don't understand what the cloud altitudes are, I will go over them in a couple of slides. But the different altitudes are the cloud management plane, the control plane, and the data plane. So how do we actually get visibility into these different levels of our cloud environment? Aside from that, how do we actually baseline our environment to understand what is normal and what is not normal? And this is a good thing to understand because it will be a good way for us to create anomaly-based detections to understand, to identify when things deviate from what is normal and abnormal in our environment. And then finally, we also have to understand that visibility comes at a cost. We have to understand that log storage is going to come at a cost, ingestion is going to come at a cost, processing is going to come at a cost. So that's one major factor to consider, because if you really want visibility into your environment, you really have to consider the cost of the visibility. So, like I said, I was going to cover, the various altitudes of the cloud environment. And previously, we looked at cloud management plane, control plane, and data plane. So what are these different planes, and how do we actually understand them? So the management plane is really your high level of what is happening with your the different people in your organizations, right? Who is making changes? Who are those people making changes? What are their permissions? What are they doing in my environment? So this is more concerned with like the processes and operations of the different roles and the different personas in your environment. The control plane is actually the activity that those people in the management plane are performing. So maybe someone is creating a virtual machine or making changes to different resources in your environment. What are they doing? Like, what policy changes are they making? What exactly is the person in the management plane doing? This is what we look at in the control plane. And then the data plane, it's a lot more into like the actual host and resources in your environment, right? Looking at your pods, your virtual machines, all of those things. And what we can see here is as we go higher in the altitude, the ease of login is the ease the login for these different planes get easier, and that means that at the data plane it's a lot harder to get login than it is at the control plane and at the management plane. So what that means is that it's easier to log things from the management plane than it is to log things from control plane, and it's easier to log things from the control plane than it is to log things from the data plane. And as we see, the other side of the arrow shows that the ease of visibility gets harder as you go down the different altitudes. So it's easier to see things from the management plane, and it's easier to see things from control plane, and a lot harder to see things from the data plane. And these are all based off of like the different ways we actually have to get these logs or have to get visibility from these different planes of our environment. So now looking at how we map all of these different planes to what we're looking for in our environment, we have to, and in relation to observability, like I mentioned, for the management plane, we're looking for the behaviors of our different IAM entities. So we're looking at, our Active Directory activity. We're looking at, our service principals. If we're dealing with Azure, we're looking at was MFA applied during this activity? Was conditional access applied during this activity? We're looking at, the different roles, like your privileged roles, like your help desk admin, your security admins. What are they doing? And also, like, this is where you also look at activity from your identity providers like Okta, Auth0, and all of those things. And then at the control plane, you're looking at, the actual activities that these different identities are performing, right? So like, creation events, deletion events, get events, describe events, all of those things that these activities, these IAM entities are going to be performing. And these entities can be anything really, it could be actual users, it can be service principals as well. And this is where you look at your Azure audit logs and your different analytics. And then finally, at the host level or at the data plane level, this is where you're looking at what is actually happening in my virtual machines, what's happening in my nodes, what's happening in my containers, right? This is where you're looking at what commands is someone running inside of those workloads, what activities are being performed inside of those workloads. And, beyond that, there are other things, you have to consider in terms of observability, like your databases, your applications, your CI/CD pipelines. So this is just a high-level overview of what to consider for login for the various altitudes. So now that we understand, how we approach cloud detection engineering, how do we actually implement cloud detection engineering, and in this case, for Azure. So one thing that is, pretty popular or has been getting a lot more popularity in the recent years is the detection engineering lifecycle, which is also known as the detection development lifecycle by some organizations. And this is basically a spin-off of the software development lifecycle, but specifically for detection engineering. And it's basically a well-defined and iterative process to build and maintain your detections. And as you can see here, it has different phases from ideation, research, requirements, development, testing, deployment, and maintenance. And and all of these different processes have some sort of alignment with what you actually do when you're developing software. So you have the ideation phase, or getting the requirements, and then all the way down to making sure you have some sort of maintenance for your software. So we're actually going to go over each of these steps and look at how do we actually use these steps to implement our detection engineering for our Azure environment. So the very first stage for our detection would be ideation. And this is where the initial idea comes, right? And when you're thinking about the initial idea for your detection, this can come from various sources. One of the first sources would be through threat modeling. And in this case, you'd want to partner with your other security teams or your product teams to understand the threat models for your products or your services or the applications in your environment. Afterwards, another way that you can actually get initial ideas for your detection is through maybe your internal threat intelligence team or maybe even external threat intelligence team that you might be subscribed to. And this gives you understanding of what are the different attacks or vulnerabilities that attackers exploit in the wild that relates to my environment that I might want to create detections for. Another way to get an idea for your detection is through previous incidents. So if you've had incidents in the past, right, whereby an attacker was able to successfully perform sort of compromise in your environment, it would be good to look at those incident response docs and look at what were the things the attackers did to get access to my environment or to perform certain activities in my environment, and how can I take certain events or certain parameters from this document and create detections for them so that if an attacker, if the same attacker or a different attacker tries to perform these same activities against my environment, I'm able to actually see that activity happening. Obviously, you'd also want to have previously had some sort of preventative measures before all of this. But what if nobody eventually implemented any preventative measures? You'd still want to be able to detect that particular activity. Another way would be through your red team engagement or your penetration testing findings. So if you have an internal pen testing team, or maybe you get external consultants to do assessments in your environment, it'll be a good idea to kind of look at their pen test report and look at what were the things they did that helped them perform all of the activities they did in your environment. Maybe exploit those vulnerabilities, establish persistence, get initial access, or even exfiltrate data. Taking a look at the pen test report is a great way to understand all of those things the pen testers did, or the consultants did, or the red teamers did to successfully compromise your environment, and then infer from that various things you can do to create various detections for your Azure environment. And finally, looking at your compliance findings. So if you have any form of like compliance findings, maybe mapped to like different frameworks like SOC 2, PCI, GDPR, it'd be a good idea to kind of create detections against them to understand if anyone would try to exploit misconfigurations or vulnerabilities that have any sort of link into those compliance findings. So with that said, now that we understand how to get ideas for our detection, I'm going to be posing a hypothetical situation that we're going to use to understand the rest of the detection engineering lifecycle. So in this case, a recent pen test revealed that a compromised user could register a rogue device to your Azure AD tenant without MFA. And what this allowed the adversary to do was to easily maintain persistence in your environment. And now you've been tasked with developing a detection mechanism for this activity. So as we can see here, our idea actually came from a pen test finding, and we're going to use this idea to then develop our detection. So up next, now that we know that someone is able to register devices in our Azure AD tenant without MFA, we now have to start doing some research. And our goal here is to get a better understanding of the threat. We have to look at the attack surface. We have to get an understanding of how Azure AD device registration works, how MFA policies works, and we also have to take a look at the pentest report because this is where the finding came from. And if this was an incident, we might have to take a look at the incident response report and also understand how the tactic and technique was used. This is really where we dig deep into the actual activity that we're trying to detect in our environment. Up next is the requirements. So the question we're asking ourselves here is, what do we actually need to build this detection? What log sources or data sources do we need? In this case, it would be your Azure AD logs, your sign-in logs, or maybe your Microsoft 365 logs. Another thing to consider here is your detection pipelines. Do you have the right log parsers for these different logs? Do you have the right event parameters that are required to actually detect this activity in your environment? Up next is the detection mechanism. So how are we going to what are we going to use to detect this activity? Is it going to be with a platform or maybe with an agent, right? And then finally, we have to understand the how to, the type of detection you're going to be doing. And I mentioned earlier on that a good way of understanding the detection is a good way of baseline your environment. A good thing to do is to baseline your environment in order for you to understand what is normal or abnormal. So it'll be good to like have some understanding of what's normal, and that way you can define detections for anomalies. Another thing that's also popular is using threshold based detections, where you're trying to identify when an activity happens a certain amount of time. So if this happens one time or two times or in this sequence, that's where you're going to be using threshold based detections. So after you've identified the different requirements for the detection, you then start, looking at how to actually develop the detection. So this is where you use the concept of detection as code. And with detection as code, there are different aspects to consider for detection as code. And I'll be digging deeper into what exactly the detection as code is. But for now, what we have to really think about for our detection as code is our query, our logic, the detection itself, how we're going to alert, and also the different tags for our detection. And detection as code can actually be done with Python. It can be done with JSON and also YAML. So most of the detections for popular tools like Sentinel, Azure Sentinel, and Splunk are actually written in YAML, but the actual query language is embedded in the YAML file. So if you take a look at Azure Sentinel's repository for various detections, the actual detections are written in YAML, but the actual KQL queries are embedded in those YAML files. And then same thing for Splunk. The Splunk detections are in YAML, but the SPO queries are embedded in the YAML files. So YAML is pretty universal. I'm going to be looking a little bit deeper into how you can use Sigma, which is also YAML based for detection as code. So a quick example of how you can use Python for detection as code is actually from the Panther website, and they use Python for the detection as code, and this is actually a Okta brute force login rule. But what I really want to point out is the different aspects of the detection. The first part is the modules, right? You're saying you're importing different modules from the Panther from Panther, and then the second part is defining what exactly are the event parameters I'm looking for in my logs. Most of the time, the logs are typically in JSON format. So you can see we're looking for, the event outcome, the result, and when any of those two parameters appear to be a failure. And also we're looking for an event type that has a parameter of user session start. That's the first thing we're looking for. And then finally, when we find those parameters, we want to alert on, what exactly happened. And we have this really nice template that gives us exactly what happened. So this is a high-level overview of how you can do detection as code using Python.
Yeah, Dave. Dave, I got a question from one of the audience. I just want to drop in quick before
Yeah.
you proceed. So Hakeem asks, is cloud pen testing same as cloud detection engineering? And he have a follow-up question as well, that how can someone build a career in cloud detection engineering and the prospect?
So cloud pen testing is, very different from cloud detection engineering. So I don't have an official definition for cloud pen testing, but if you understand what traditional pen testing is, it's basically, working to identify vulnerabilities or break into environments to find, what weaknesses or vulnerabilities are in those environments. Basically, ethical hacking. And if you apply that to cloud, to cloud, it's basically the same thing. Breaking into the cloud environment to identify various vulnerabilities, then reporting on those vulnerabilities, for remediation. So in that case, it's totally different because our goal for detection engineering is actually to identify the activities that would probably be generated by a cloud pen tester or an actual adversary. So a cloud pen tester's job is basically to just find ways to get into the environment, compromise the environment, and let us know how you did it. But the cloud detection engineer's job is to identify how does the cloud pen tester do this, and how can I catch the cloud pen tester or the actual adversary when they're doing this. And then in terms of building a career for cloud detection engineering, the great thing about it is you can come from almost any major technical security background. So in terms of for me personally, I come from a security operations background, mostly dealing with like hybrid environments. But that was great for me because I had an understanding of like what should be happening in the environment, also dealing with different kind of alerts and detections. So that kind of helped me understand like what do I want to look for in a cloud environment and how do I detect it, and also like what were the things that I didn't enjoy while I was working as an analyst that I would want to implement into a cloud sim or a cloud security tool that would definitely help the analyst have a better investigation workflow. So you can come from different backgrounds. You can also come from a pen testing background or a cloud pen testing background, because that way you understand how adversaries actually compromise cloud environments, and then you can apply that knowledge to identify ways to detect those activities. So those are not the only two options, but you can definitely, as long as you have a solid understanding of security and you can infer from your previous background, it's really good because that way you can apply the knowledge from your previous experiences to how you want to create detections for the cloud environment.
Awesome. Thanks very much for that. Thanks very much for for answering that question comprehensively. So another quick question, and just to ask in context before you go on with the rest of your amazing presentation. So Fogg asked a question: can I use DevOps? And I'm thinking this is in relation to when you were talking about detection as code. So is that something that you've seen people implement, like DevOps processes around that? Because when you start implementing detection as code.
So I think this person is referring to Devo, which I believe is a tool.
Oh,
Uh,
is it? Okay.
yeah,
Okay.
I think it's either like a login tool or so. I'm not too familiar with
Oh,
Devo, so
because
I
I
can.
asked, I said, do you mean DevOps? And he said, yes, I'm referring to DevOps. So I
Oh,
thought he was
DevOps.
referring to
Oh,
DevOps.
okay.
Yes.
So I mean, like I would want to elaborate on that question more. Like, what do you mean in terms of like DevOps? Can you use DevOps in what sense?
Yeah. So I was thinking that I meant in terms of like detection as code. So now that we have our detection as code, now maybe iterating over that, maybe that's something that you've seen being used practically, or is that something that it's not matured up to that level yet?
Oh yeah, so like a lot of DevOps practices are used, when we're doing detection as code, right? So we're using like CI/CD pipelines, where we have the major. I mean, pretty much all of the DevOps practices are used, right? We use containers, infrastructure as code for deploying our environment. So like a lot of things that we do in cloud detection engineering are essentially powered by DevOps practices. So absolutely.
Mm, awesome. Thanks very much for that. So we'll let you carry on with the rest of your presentation. Thanks.
All right, sounds good. So just kind of, so we just went over looking at detection as code in Python. So we're looking at after development, we go into testing. So, and as a matter of fact, all of these things are, part of like, what a lot of DevOps practices cover, right? So how do we actually test that our code is proper? How do we validate our detection, first of all? And validating our detection means like, going in and actually manually emulating the attack to understand if this detection works as designed. Maybe we can go and look at how the pen tester, performed that compromise in our environment. How did the pen tester establish persistence using that rogue device to get access to persistent or Azure AD environment? We might actually want to manually emulate that to see if we're actually able to detect the activity based off of what we've developed using our detection as code. And we could also use automated detection validation using tools like Stratus Red Team, which is basically a framework that has various sort of like attacks for cloud environments, including Azure, AWS, and GCP. And then Atomic Red Team also has similar capabilities. It was traditionally built for on-prem environments, but they've recently been adding some attacks for Azure. So there could be those could be some automated tools that you can use to validate your detection. And then you can also write your own scripts, maybe to generate logs or to generate specific activities that you want to see and use to validate your detection. Beyond just validating the detection, we also have to have some sort of unit test to make sure that our detection as code is properly done. So we don't just like get the code and write the code, and because it works as we want, we just push it to production. We have to make sure that everything in our code is designed as we want it to be. So we have to create tests for to make sure we have the proper queries, we have to create text to make sure that we have the proper code format, to have the proper tagging, the proper detection parameters. So everything we want to make sure is properly done in our detection as code. We have to create various tests to make sure that these things are properly done. And a lot of times, this is typically done using Python scripts to look for specific parameters in the detection as code. So after we've done, the testing, then we push the code into development, into deployment, and this is where the code is pushed to production. So before you push to production, just like before you push any code to production, you definitely want to get peer reviews from other detection engineers, maybe your security peers, from your incident response team, maybe even the pen testing team, or adversary simulation, adversary or the red team team that perform the activity. Try to see if they can review it for you. Maybe your internal security team. Just basically getting the proper eyes on the detection before you push it to production to make sure it's properly done. And then after we've pushed this detection to production, we also have to make sure that we continuously maintain the detection. So just like normal software, we have to make sure that we add and manage version control. So if there are any changes made to this detection, how do we track those changes? How do we make sure that no one is just making any changes, and we know what changes are being made and when they're actually being made to the detection? Also, we will look at maybe adding things for the analysts who are going to respond to the detection. So maybe response and triage elements for ease of for the analyst. And then also during the maintenance phase, how do we actually look for ways to improve this detection? Are there any things we can add to the detection to make sure it's doing what it does a little bit better, or giving it more context by maybe adding some sort of enrichment? Another good use of your threat intel is to add enrichment to your detection. So let's say you're doing like IP-based detection. You want to look at if I can get some sort of enrichment from some IP provider that can let me know when certain IP addresses are suspicious or malicious. That way, it gives more context to your detection to identify if someone is logging in from a suspicious country or an IP you've never seen before. Another thing to consider is tuning the detection. So detections sometimes can be pretty noisy. I'm sure anyone who has worked in a security operations environment is familiar with like alert fatigue. So understanding like what can we do to tune this detection and make sure it's not just firing just false positives is important. And here you evaluate your threshold, you evaluate the alerts, you evaluate the queries, and you even like maybe make some suppressions for your detection. We also have to look at how do we alert when this detection is fired. Like, who do we send an alert to? Are we sending an alert to a platform? Are we sending it to Slack? Are we sending it to a security administrator or a security analyst? How does someone get to know when this detection is fired? Another consideration is automation. So like one thing that we try to consider a lot is like how do we automate response for this detection? Although this is a lot more of a response activity, but we still want to consider like what can we do to automate the response, maybe using playbooks or runbooks, and also adding things like dashboards to maybe enhance the detection and make it easier for whoever is going to be investigating this activity. We could also create reports, maybe like on a particular cadence, like weekly, monthly, quarterly, to help us have a high level overview of like what this detection is doing, what it's fired against, and then afterwards we can also look at how do we have a process to continuously review this detection to make sure that it's still useful and it's still performing the purpose of which we made the detection for. And finally, we also have to have a process by which we continuously test the detection to make sure that it's actually firing the way we want it to fire. It's actually detecting the activities that we want it to detect. And this is easily done through purple team exercises where you have your attacking team and also your defense team, which is going to be looking at if this detection is doing exactly what we want it to do. And finally, during the maintenance stage, we also have to look at what happens when we want to retire this detection if it's necessary. So you just don't want anyone to just go in there and just like turn off the detection or just remove it from the repository. You actually have to have a really solid approval process or a really solid defined process for how do we actually retire this detection. Like, what is the rationale behind retiring this detection? Is it because it's no longer useful, or maybe because like this particular threat is no longer common to our environment? Why? And then what are the specific metrics or the specific information to justify us actually retiring this detection if it's necessary? All right, so I know I mentioned some things about detection as code, so I wanted to dig a bit deeper into exactly what detection as code is and give you some examples of how it works. So, as you can see, there are three different layers, and these are the different building blocks for your detection as code. So the fundamental piece of your detection as code is your query. This is the foundation of your detection. This is the specific attributes and parameters that define the adversary's activity in your environment. So this is what exactly we're looking for. Above that is the logic, and this defines the methodology of your detection. This is where you actually have your and statements or your or statements, just pretty much logic statements that define the thresholds for by which you want this detection to fire. Basically, the thresholds and the logic for the query you created in the first stage. And finally, anything that's outside of that is your enrichment. So this is where you add things like your metadata. This is where you add tagging, exclusions, suppressions, all of those things that I mentioned in terms of the things we do to during the maintenance cycle, the maintenance phase of the detection. So we're actually going to look at a breakdown of detection as code with Sigma, and we're going to use the example of the device registration or join without MFA that I mentioned earlier on from the pen test report. So as you can see here, this is a Sigma rule that shows that monitors and alerts for device registration or join events where MFA was not performed. And this is available on the Sigma GitHub page, and I really recommend you just go on there and take a look at the different detections they have for Azure and for other various platforms, and just look at how these different things are done, and really understand the concept behind how these different detections are built up. So let's break down this detection into its different building blocks. So the first part that we talked about was the query, and the query, like I said, is the specific things we're looking for in the logs, and the query covers what is the log source. And if you remember, we talked about our requirements, like what what log sources are we going to be using for this detection, and we mentioned Azure AD logs, we mentioned sign-in logs, and we measured Microsoft 365 logs. In this case, we're looking at Azure logs, and we're looking at the sign-in logs that are that are being used for this device registration. And then we see for the selection, we're seeing the device registration service. We see when the activity is successful, and also a parameter for multi-factor authentication. So those are the specific parameters we're looking for in the logs. Then the logic, this is like I said, this is like the and or statements, and also like the thresholds for that we're defining this detection for. So in this case, we're looking at the selection, which covers the device registration service, successful activity, and then we also have a not statement. Remember, we talked about logic statements, so and statements or statements, not statements. If you're familiar with like querying, these are typically used to maybe identify negatives in the logs that we don't want to identify in the logs. So in this case, we're looking for any logs that don't have the multi-factor authentication activity in them, because we're looking for the activity without MFA. So understanding how those different logic statements work is really great when you're building out these detections. And then finally, we're looking at the different enrichments. So the enrichments basically taggings, metadata, and you could pretty much have almost anything you want here. You could even have like information about what environment this activity is happening. If this is like in your prod environment, your dev environment, you can add that information here just to enrich the detection. And like I mentioned earlier on, another way to enrich your detection is through your threat intel data. So if you are using like IP, if you have an IP based detection, maybe for like impossible travel, a good way to really enrich that would be use your threat intel data to identify if the IP address is suspicious or malicious, and that gives more context into your for your detection. So pretty much everything you add to the detection to give it more meaning or to improve the detection will be considered an enrichment.
Right. Dave, before you move on, we got a question in regards to the Sigma from Jamari. Jamari said he wanted to know, did you start detection engineering with strong Sigma and programming knowledge?
So I was familiar with Sigma before I started doing detection engineering. I wasn't using Sigma professionally, but I had played around with it on my own in labs, but I didn't use it professionally. So I wouldn't say I was strong with it, but I did understand it fundamentally. And in terms of programming knowledge, before I got into detection engineering, I have previously taken a C++ class in college, but I can't tell you that I learned anything much from that. I've also tried to teach myself like Python multiple times, but I wouldn't say I had a strong understanding of any of those two things before getting into detection engineering. The great thing about it, about my role and about what I do is like over time, you really get to like understand it and get better at it as you go, as long as you put in the effort. But I wouldn't say I had any strong knowledge of it. It just like you just get better at it and understand it better, over time by just like using it every day and working with it every day.
All right, that's amazing. All right, thank you.
Of course. So after we've considered everything, so we just looked at the entire detection engineering lifecycle, and also how detection as code works with Sigma. Then we have to another consideration would be how do we actually architect resilience into our detection. So one of the major pillars for our architecture in cloud environments is resilience, making sure that we have things in place to mitigate failure in our cloud environment. And one thing that really helps us to mitigate quote unquote failure for our detections, because sometimes our detections might actually fail, is to look at detection in depth. And this is kind of like a play on the defense in depth concept. And when we're looking at detection in depth, we're looking at different things. And the four major things I highlight here are precision. So what can we do to make sure that we have as precise of information that we need for this detection? And this can come from our queries, like what are the specific things that precisely define what we need to detect the activities we want in our environment. And then we also have to look at detection from different layers, right? So what if the detection at this layer fails? What if an adversary is able to kind of bypass that detection, or is able to get into our environment without that detection firing? Do we have a detection at a different layer that would help us catch the activity or catch the adversary's activity based on known tactics or techniques? And then we have to consider blind spots, right? Are there things we're not considering in this detection? Are there things that we're turning a blind eye to? And sometimes these things might actually be trade-offs, because we might not have enough in terms of requirements, like we mentioned earlier on. Maybe we don't have the right logs or the right parameters to detect these things, but we also have to consider those things, like what are those blind spots that might exist, that might affect the depth or resilience of our detection. And like I mentioned earlier on, in terms of the layers, we have to consider what are the different things the adversary might do to evade our detection. One good example is if you are using Metasploit, you want to make sure you're not using like the default port. So if an adversary is trying to maybe use Metasploit against an environment, right? They might try to, and you have a detection that only just like detects like the default port that a Metasploit exploit might use, then that's an easy way an adversary might be able to evade the activity. So in referring that to our cloud environment, if an adversary is using specific tools or tactics or techniques in our environment, we have to consider like what might the adversary do to evade our detection, and how do we actually identify the adversary's activities to evade our detection. So our goal here is just really to implement as much to make sure that our detections are resilient. If one detection fails, or if something in our detection fails, there's something to help us identify that and make sure that we have depth and resilience for our detection. And then finally, democratizing your detection function. So when we think of democracy, we typically think of people that are by the people, for the people, all of that. And you typically think of a leader, someone that represents the people. And this is also a play on the security champion. If you're familiar with like this in terms of like DevOps, one of the things that is important is highlighted in the DevOps culture is having like a security champion. And in this case, I'm applying that same concepts to having a detection champion. And this could be anyone in your security team or your detection team who basically has these different characteristics, right? So having the technical competency across various technologies, because as a detection engineer or as a cloud detection engineer, you're expected to have your competencies across the various Azure resources, the various Azure methodologies, everything that is compromised about that is comprised within Azure. You would be expected to have some sort of technical competency across those various things. And then for the detection champion also has to be able to create awareness of your detection team. So one thing that can really help your detection team is making sure that you're partnering with your other teams, right? That actually own the different assets or own the different aspects of your cloud environment, right? So like your security team might not own like the various assets or tools or things, infrastructure being used in your environment. So you have to be able to like communicate and have some sort of awareness for those of your organization with those other teams, so that way you can collaborate with them in terms of like creating detections for the different tools or infrastructure in the environment. And this would involve collaborating with your development team, your operations team, your security teams, and your other teams. And when you have a strong collaboration with all these teams, it makes your job a lot easier as a detection engineer, because like sometimes you might not even have to do the ideation for your detections, right? If you're looking at threat modeling, like your developers, might be able to like give you ideas, or might be able to like collaborate with you in identifying ways that you can create detections for their different applications or the different resources that they use for the development or operations work. So being able to like collaborate with these teams is going to be really really important, and also not being like an inhibitor for their work. And then finally, being a detection champion also involves like mentoring junior detection engineers, because you have to make sure like you're creating a solid pipeline for the younger generation of people who are gonna eventually possibly take over the work you're doing in the organization, right? That means like maybe mentoring them technically, also creating resources and creating an environment where they can thrive, and where they can continue to grow, because the detection is a lot more beyond just the technical piece of like building out the detection and writing the code, testing the detection, testing the attack, all of those things. It also involves like the people and and the processes that are actually involved for and with the detection. So all of those things have to be considered, and the detection champion is that person who typically takes up that responsibility, or it might even be a team, right, that would take up that responsibility. So just putting it all together, where we covered, what cloud detection engineering is, basically identifying suspicious activities in our cloud environments, and also being ahead as defenders. We covered how to approach cloud detection engineering. So, understanding what the adversary is doing, the different considerations for observability, which would be like telemetry, login. We covered like the different cloud altitudes. We covered how to actually implement our cloud detection engineering using the detection engineering lifecycle, using detection as code, and also finally how to operationalize our cloud detection engineering function by making sure we have resilience for our detections, and also having a detection champion or a detection championship program. So these are all the different sources and additional references, and all of the slides will be available on my GitHub. But yeah, that's it for me. Thank you all so much for listening.
Awesome. That was amazing. Thanks very much for that, Dave. Thanks very much for that. Now we do have a few questions that Sakofi and myself we sort of go through. We also have some questions of our own. So I mean, there's a lot of concepts that you've covered. You've covered concept of detection engineering lifecycle, detection as code, detection in depth, the democratizing detection function. There's a lot of concepts that I need to go study up on after your session today. So thanks very much for sharing all of those with us.
Absolutely.
One of the popular questions that's come up is, are you going to be sharing your slides? The slides are so good. So people are asking, will you be sharing
Yes.
that?
Yes, they're already publicly accessible on my GitHub, Daycyberworks slash Azure Detection Engineering. All of them are going to be they're already there, so you can just check them there.
Do you
Okay.
have that a GitHub link on your
Yes,
slide by any chance?
it's not on the slide, but I can drop it
Oh,
in the chat right now.
okay, that would be great, please.
Yeah, just
Awesome.
dropped
Yeah,
it.
thank you.
Thanks for sharing that. I'll definitely also be checking that out myself and getting a lot of information from that. So thanks very much for sharing that. So another question that came up. So this one came from Doctor. so and I guess like because we're talking about cloud, the detection engineering for the cloud. So it's like, do you lab in the cloud or do you use on-premise servers?
So yeah, I mean everything we do is in the cloud, like Azure, AWS, GCP. If we're going to be doing cloud detection engineering, like everything we do in the cloud. I mean, of course, like we use our our on-prem computers to do all of the like to make all the API calls, but all of the things we're doing is for the cloud environments and are in the cloud environment. So like when we're dealing with like detection engineering cloud, like we have to make sure like it's actually in the cloud because that's where we're doing the detection for, and that's the only way we can actually validate that what we're doing works. I mean, of course, there are cases where you might have some sort of like hybrid considerations, which might be different. But if you're doing detection engineering in the cloud, you're gonna have your lab in the cloud.
Okay. So, and also just to follow up with that, is there like are there any good, like maybe automation template for building out maybe test environments that that you can recommend to people?
So there are a bunch of labs out there that come with like their own like I guess Terraform script and stuff like that. But they're mostly just they're mostly for CTF environments. What I would recommend is so I created a guide for different resources that can help you learn about cloud security. So I'll actually link that in the chat right now, and that covers a bunch of like various cloud labs that you can use to have those like those insecure environments that you might that would be good to play around with to test stuff.
Yeah, we got another question from Doctor. He said, "How can one become a cloud detection engineer?"
So I'll give you my own personal experience. So I was working in security operations for about a year and a half before getting to Datadog, working in cloud detection engineering. So that was my previous experience, right? So working like using working as a security analyst or a threat analyst, working with various like security tools for both on-prem and cloud environments. So that definitely gave me some, baseline security experience and some experience that I could apply to my detection engineering role. So that was definitely helpful. So you coming from a different background could be really good if you've worked in like security operations, if you've worked as a cloud engineer, maybe not even security specific. That could also help if you've worked as a DevOps engineer. If you've worked in a previous IT or like operations or cloud role, you can definitely pivot into cloud detection engineering. But if you are coming in with like no experience, it might be a little bit more difficult due to the lack of experience. But you can definitely build that experience yourself, by actually working on labs that would actually show that you have the skills to perform the activity. Because like as cloud detection engineers, we actually look at things from like different perspectives, both like the offensive side and the defensive side. So maybe practicing like those offensive cloud techniques that are covered in various like cloud blogs and stuff like that, or videos, and just looking at how they look like in the logs and actually learning how to create those detections. That way you can show that you have the skills or the foundational knowledge to actually perform the job. And I'll recommend creating like a YouTube channel or a blog or GitHub to document these things. That way that you can share with like people or employers or whoever you're interacting with, to show that, hey, I might not have had the work experience, but I've played around with these things in my lab, and I can build on this, to get better, at the job. So that'll be my recommendation.
Wow, that's really amazing. Yeah, actually, we got another follow-up question around the same sort of like top area, because you actually do a lot. So Danny was asking a question: how do you balance your full-time job with content creation? And I mean, obviously, you do tutoring as well. How do you do the balance?
So for me, it's just like prioritizing like what I'm doing. So like for me, like right now, my major priorities are like, my job, my tutoring, and also like, college as well. So like, right, I actually, took a quick break from content creation. I haven't posted any videos in like 3 weeks now because I've been really trying to like get some classes done for school. So for me, it's just really, prioritizing, right? So for example, I really want to like maybe complete this class for school. So that might mean I have to take like a break from like content creation for a while. But if it helps me achieve my goal of like completing this class as soon as I want to, then it would be worth the sacrifice. So like just prioritizing the different things you're doing and understanding like which one is of the most importance right now, and how soon can I complete it so I can get back to the other things I want to do, and also just being like whatever you're doing, like do it with full intent. So if you're working, like focus on work, don't have any other sort of like distractions. Like I personally don't think that we actually have the natural ability to multitask. So like if you actually focus all of your time and energy on what's thing you're specifically doing, get that thing done and then move on to the next thing. That way that you can easily like, plan out your time across the various things that you might have to do. If you're trying to multitask, like you're pretty much spreading your energy across multiple things at the same time, and you probably wouldn't get anything done at all. So just prioritize what you're doing, focus on what you're doing, try to avoid, distractions like social media, all of those things, minimize them so you can, actually get efficient at what you're doing and get things done, like the way you want to do them. Like there are many people out there who like do multiple things. Like Elon Musk has like 3 or 4 companies he manages at the same time. There are various people out there who are doing multiple things. It's just about prioritizing and really just paying attention to what you're doing at every single point in time.
Wow.
Awesome.
That's really amazing. I mean, if you want to refer a book that someone have to read, which book in particular are you going to recommend?
So I actually have a ton of books that I would recommend. First one I would recommend is Deep Work by Cal Newport. That's a really great book. I highly recommend it. I did a video of it on my channel. Another one I've actually been recently reading is Indistractable. I forgot the name of the author. That's another good one. I would recommend Digital Minimalism by Cal Newport as well. That's another good book. Atomic Habits is a good one as well. Just building like really, really good habits. And then let's see, bunch of them. Then another one is also Ultra Learning. That's a good one if you really want to have a good framework for like how to learn hard things and complex things. Because like a lot of times when you're dealing with like cloud environments and things in the cloud, as you scale and as you consider security, a lot of things get really complex and you have to learn those things. And sometimes on the job you have to learn those things fast. So Ultra Learning is a good book that will help you like have a really good framework for learning like how to those hard concepts and learning them fast enough to be able to like understand them and grasp them very well. So those are my recommendations. You can find all of those reviews on my channel because I've done reviews for them.
Yeah. Awesome.
Absolutely.
Thanks very much for that, Dave. That was an amazing session. So again, just a quick reminder to everyone, if you're yet to join the Meetup group, ensure that you do use the link that we've shared earlier to join the Meetup group. This video will be is recorded and will be live on YouTube immediately after this session. So also, if you're yet to, make sure you like the video. Again, I've got some follow-up questions for you, but that'll probably be for another time because you've shared lots of amazing concepts with us that I think that I'm going to be following up on in terms of my own study. Again, the detection engineering lifecycle, detection and soul, detection in debt, and democratizing the detection function. Those are all amazing concepts. I think they are worth diving into. But that'll be it for today. We've gone a little bit over time, but it's worth it. So thanks very much, Dave, for joining us. Thanks very much, Sir Kofi, for not only joining us, but also for sponsoring us, with all the gold investments that you put in. We appreciate you greatly. And thanks very much to the audience for joining us also. See you next time. Have a lovely day, afternoon, evening, wherever you're joining from. So see you, everyone. Bye for now.